Okay, let's start. This is May, June. This is February, March, 6 2, and I don't know the markings. Yeah, 6 2. Okay. The first question says the length x centimeters of 106 of a certain item, certain type, were summarized as follows: calculate an unbiased estimate for the population mean and variance. Okay, so unbiased population mean is simple. It's 36.8 divided by 100. ओके, तो ये हो जाएगा 0.368। स्टैंडर्ड डिविएशन के मीन वेरिएंस चाहिए। वेरिएंस के लिए सिंपल सी बात है कि आप करेंगे 100/99 और फिर 17.34 डिवाइडेड बाई 100 माइनस द मीन स्क्वायर विच इज़ 0.368 स्क्वायर्ड। तो ये वैल्यूज लगा के देख लेते हैं जल्दी से। 17 डिवाइडेड बाई 100 माइनस 0.368 स्क्वायर्ड 100 डिवाइडेड बाई 0.0803841। Okay, so that's the first correct. State a necessary condition for the estimate to be reliable. Sample was random. Yeah, I hope that's the correct answer. Yeah. Random sample of 250 people living in Biopet was chosen. It was found that 70 of these people owned a BTech font. Calculated an approximate 98% people interval for the proportion of people living in Biopet font. Okay, so 98% confidence interval. What am I going to read from my past formula sheet? I'm going to read 99%. That's 2.326. Okay. Okay, 2.326. So X, it's for the proportion. So 78 out of 250. Is that a reduced decimal that I could take? 0.312. So I'm going to write 0.312 minus Z value 2.326. 2.312 into 1 minus is 0.688 over n 250. Okay, that's the upper boundary. Lower boundary is 88 over 3. Point 0.80. Okay, those are the correct answers. Moment. Okay. Manjeet claims that more than 40% of the people living in Barraquet own a BTech phone. Use your answer to part one. So 40% is within this, is outside this interval. So Manjeet's claim is wrong. Claim is wrong because not inside the interval. Okay. Okay, then it says in a country, in a certain lottery, on average, one in every 10,000 tickets is a prize-winning ticket. An agent sells 6,000, so he sells 6,000, but the probability of winning is very small. It's 1 out of 10,000. Okay, so use a suitable approximation. So I'm going to use a Poisson instead of a binomial. Find the probability that at least three of the tickets sold by the agent are prize-winning tickets. So I'm going to say n is 6,000. P is 1 over 10,000. So what is NP? NP is 0.6. Okay. So lambda is equals to 0.6. I will calculate the probabilities of 0, 1, 2 and subtract them from 1. So e power minus lambda minus e power minus e power minus lambda into lambda power r 1 minus 0.977. Zero two three one to make sure that I round off too early. I have rounded off too early. It will have been 9 7 something else. Was but okay. Rounding up error. Justify the use of your approximation. N is large, greater than 50. P is small, less than 0.1. Okay. So must state values of n in either np or p, not n large, p small is insufficient. Okay. So 6,000 is greater than 50 if we state it for 10,000 less than. Okay. Each year a transport firm uses X liters of gasoline and Y liters of diesel fuel for X and Y. And this, find the probability that in a randomly chosen year the firm uses more gasoline than diesel. So G minus D is the variable difference minus D. Okay, they are X and Y. Sorry, so X1, X9. So mean is for X minus Y is 10,700 minus 13,400, which is minus 2,700, and variance is added together 950 squared plus 1212 236. Okay, so probability of b greater than 0 minus 100 divided by root of 2 gives me b greater than 1. Okay, 1 minus 5, 1,755, 1.9603. 0.039. Okay, then the cost per liter of gasoline and diesel are 0.8 and 0.85. Find the probability at the total cost. So total cost is 0.8x plus 0.85y, and the total is between 20,000 and 22,000. Okay, so I will have to come up with the mean of t. So it's going to be 0.8 times 10,700 plus 0.85 times 13,400. That gives me 19950. And for the variance, what I'm going to do is I'm going to do 0.8 square into 950 square plus 0.85 square into 1210 square. Okay, that gives me a very large number, 16541. Okay, so 20,000 0 3 2,000. Okay, let's calculate these numbers. New 0.039 1.603. Let me check if these numbers are fine because I don't want to end up calculating useless numbers. 0.039. But I can only calculate 0 to 3 decimal places. So, uh, where is formula sheet? So phi of 1.603 minus phi of 0.039, 1.603, 603, 9455, 039, 0.03, cancel that. 5156, 5156. Okay, let's check if I've read this correctly. Right. Yeah, I've read these correctly. Let's calculate 0.4299. Okay. In question 5, a teacher models the number of girls and boys who arrive late for a class on any day by the independent random variable this. Find the probability that during a randomly chosen 2-day period, no girls arrive late. In a 2-day period. So lambda is going to be changed. 0.2 e power minus lambda. 0.8187. And 819. Okay. Find the probability that during a randomly chosen 5-day period, the total number of students who arrive is less than 3. So the total number of students is 0.25 for one day. So the total number of students is 0.25 for one day. For 5 days, it's 1.25. And I want less than 3. So I want the probabilities of 0, 1, and 2. So e power minus lambda plus lambda e power minus plus e power minus lambda to lambda power r for 0.86. Okay, that's correct. It is given that the values of G and R are G equals to R and B equals to R are very small and can be ignored. Find the probability that in a randomly chosen day more girls arrive late than boys. Okay, so I will have to make cases. Girls, more girls arrive late than boys. It could be the case that two girls arrive and no boys arrive, or it could be the case that the internet fluctuating. Let's record this: two girls and one boy, and then I have one girl and zero boys. Okay, those are the values that could uh, work. So for two girls, I have girl square point one and point one. So e power minus point one into point one power two over factorial into e power minus point one. E power minus point one into point one square over two factorial. E power minus 0.15 into 0.15 power 1 over factorial. And then e power minus zero point 0.1 is, into 0.1, 0.1 to e power minus 0.15. I think those are the cases that I should calculate. Those are tough to calculate, so let's do them quickly. Okay. E power minus zero point 0.1 to zero point 0.1 squared over 2 to power. What knows what's going on right now? Power. Giving a 0.0824. Answer 0.08. Then following a timetable change, the teacher claims that on average most students arrive late than before. The change during a randomly chosen 5-day period, a total of 4 students arrived late. That's the teacher's claim. I am going to need each not. So the total for 5 days came out to be 0.25 or 1.25. So lambda was 1.25. The teacher claimed that more students arrived late. So greater than 1.25, 4 is the test statistic. Okay. So I will calculate the probability of x greater than or equals to 4, which means that I should calculate 0, 1, 2, 3. subtract from 1. I'm not writing down all the numbers, but I'm just going to calculate to uh, the total 0.967, so 1 minus 0.3, less than significance level, reject H naught. There is evidence that more students are coming. Okay, then Question 6 is the graph of the probability density function of a random variable is symmetric for the line x equals to 2. So it could be anywhere, is given that the probability from 2 to 5, okay, let's say from 2 to 5 is 117 over 256. Okay, using only this information, show that probability of x greater than minus 1 is 245 over 250. The idea is that the distance between 2 and 5 is giving you the probability 117 over 256. That means that there's symmetry. Then up till minus 1 also, this area should be 117 over 256. So what's 117 into 2? It's 234 over 256. But I'm not just asking you for up till 5, I'm saying greater than minus 1. So this remaining area should also be there. Now, what you should understand is that this area should be 0.5. So how much is left over? 0.5 minus 117 over, that's 11 over 250. So what I'm going to do is, for probability of x greater than minus 1, I'm going to take 2 times 116 plus 11 over, gives me, okay, that is the working that I should actually show in order to get the answer. Okay, it is now given that for x in a suitable domain, f of x equals to this. Okay, find the value of k. So can I find out the turning point of this? The turning point of this should be minus k over 2a. That's 4 over 2. That's 2. What are the two intercepts? That's what I could find out, because I would want to know where the graph is positive. So this gives me, if I solve this quadratic, so x equals to minus 6. Can I then say that if I integrate from minus 2 to 6, that gives me the turning point as well? So 12 plus 4x minus 4 should give 1. K comes outside, minus 2 to 6. I have 12x plus 4x squared over 2 minus x cubed over 3, 1. Then k 12 times plus 2 times square minus 2 over 3. Upper limit. lower limit equal 1. Calculate these numbers. 4, 8, 256 over 3. That gives me 3 over 2. Answer. We have taken a domain from 2 to 5. That is given as mine. Well, that's also fine. I could have used this number to calculate. Well, I think I would uh, yeah, minus 2. That's also allowed. Okay, so part C says a different random variable x has the probability density function this. Uh, and what I need to calculate is the domain of f of x is all values for which g of x is greater than or equal to 0. So when is g of x greater than or equals to 0? Let's find that out. So this is a quadratic inequality. I think my calculator can solve this directly. I can also solve this manually if I want. X square minus x minus 2. So x is going to have two values, minus 1 and 2, when it is less than 0, when x is minus 1. Okay, then for the variance, what I have to do is the variance of x is x squared f of x minus the mean squared. Okay, I don't have the mean squared. Let's first calculate that. Mean is basically integration of x f of x from minus 1 to 2. So x f of x. So 2 over 9 outside, 2x plus x squared cube over 3 x cube. And then integrate that to x squared over 2 plus x cube over 3 minus x power 4 over 4. So the 2 over 9 outside. So 2 over 9 and minus 1. Okay, I'm going to put that on my calculator quickly and out the integration is plus x squared 9 over 4. So 2 over 9 into 9 over 4 gives me half. That's 0.5. So that's 0.5 squared. 0.5 squared is for x squared f of x, you get 2x squared plus x cubed minus power 4 integrated 2 over 9. So 2x cubed over 3 plus x 4 over 5 over 9 side. Limits are 2. Gives me 7 over 10. So 0.7 minus 0.5, 0.45. Okay, question 7. Then the heights in centimeters of adult females have mean, mu, and standard deviation this. It is known that in 2004, the values of mu and sigma were this and that. So government claims that the value of mu this year is greater than it was in 2004. In order to test this claim, a researcher plans to carry out a hypothesis at the 1% significant level. He records the height of a random sample of 300 adults in female this year and finds out the value of the sample. Okay. So government is claiming that mu is no longer 168.21 and it's that greater than 160.2. Here's the probability of a type 1 error. So that is just simply 1%. Okay, so we out about that. You should assume that the value of sigma remains at 6.95, given that the value of mu is, find the probability of a type 2 error. So if you want to find the probability of a type 2 error, you will first have to find the rejection region on this. Okay, how do you find the rejection region? You first state your null and alternate, which I've already stated. And 1% significance level would mean 99%. 9 gives me to 6. So I'm going to convert this z value to a value for x bar and say that x bar minus 153.1 divided by 6.95 divided by 2.326 x bar. Okay, so the x bar translates to 164.14. So if x bar was greater than this region, I would say that it's in the rejection region. So the rejection region would be x bar greater than 164.14. So acceptance bar is less than. It is number correct. Correct. So probability of the acceptance region with the new mu is 3 less than 164.14 minus 164.9 divided 164.15 divided by 2. 3 is less than 0.997. That's right. The answer is the end of this exam. Thank you for watching.